Right now, somewhere on this planet, a vulture is standing over a dead animal that's been rotting in the sun for 3 days. It's swollen, it's leaking, it smells like death itself, and the vulture is eating it like it's the best meal of its life. If you did that, you'd be dead within hours. Same planet, same rotting flesh, same bacteria crawling through it. But one of you survives and one of you doesn't. So what's actually different? Is it the stomach? Is it the brain? Or is it something even stranger, something that has nothing to do with biology at all? Let's start with the vulture, because the vulture is not normal, not even a little. A vulture's stomach acid sits at a pH close to 1, sometimes lower. For comparison, that's roughly the acidity of battery acid. Human stomach acid, by comparison, sits around pH 2, which sounds close. But the pH scale is logarithmic. That means a vulture's gut can be up to 10 times more corrosive than yours. That acid isn't just strong, it's a kill switch. Researchers studying black and turkey vultures swabbed their faces and found more than 500 different types of bacteria living there, including anthrax, botulism, and cholera. Then they checked what survived the trip through the vulture's gut. Out of those hundreds of bacterial species, only a small fraction made it out the other end. Everything else, the diseases that would kill a human in days, simply dissolved. So the vulture isn't tolerating the bacteria, it's incinerating it. Its entire digestive system evolved into a mobile sterilization chamber, built for one job: turn poison into calories. Now here's where it gets interesting. Because your disgust at that same rotting carcass isn't really about your stomach at all. Your stomach acid is actually fairly capable. It kills a lot of what you swallow. The real defense isn't happening in your gut, it's happening in your brain. Before the food ever reaches your mouth, in the 1980s, psychologist Paul Rozin at the University of Pennsylvania ran an experiment that sounds almost too simple to matter. He dropped a sterilized cockroach into a glass of juice, let people watch it happen, then removed the cockroach and offered them the drink. The juice was perfectly safe, nothing in it had changed, and almost nobody would drink it. Rozin called this contamination sensitivity, and it revealed something important. Disgust doesn't wait for evidence of danger. It reacts to the idea of danger. Your brain doesn't run a chemical analysis on rotting meat before you gag. It sees the color, smells the compound, and makes the decision in a fraction of a second, long before any bacteria could actually reach your bloodstream. Rozin's research traced this reaction back to something much older than culture. He argued that disgust evolved out of a more primitive system, one built simply to reject bitter, toxic tastes. Over evolutionary time, that system got repurposed. It stopped reacting only to bad taste and started reacting to anything associated with disease, rotting flesh, bodily fluids, sores, decay. Your ancestors who felt a visceral wave of nausea near a diseased carcass didn't stop to analyze it, they walked away. And the ones who walked away survived to have children. The ones who shrugged it off and took a bite did not. This is the part that matters. Disgust isn't a malfunction. It's not your body being weak or squeamish. It's a warning system so effective that it operates entirely without your permission. You don't choose to be disgusted by rot. You just are, instantly, every time, whether you're 4 years old or 40. And that system is specific. Researchers studying childhood development have found that contamination sensitivity isn't present at birth. Babies will put almost anything in their mouths. The disgust response develops gradually over the first several years of life as children learn, mostly through watching adults react. What counts as dangerous, by around age 8, the reaction is locked in for good. Compare that to the vulture, which needs no learning at all. It's born with a gut already engineered for the job. Humans, by contrast, evolved something more efficient in a different way. Instead of building a body that can survive eating anything, we built a brain that refuses to eat the wrong things in the first place. Vultures spent millions of years hardening their insides. We spent that time hardening our instincts. There's a reason this trade-off makes sense. Vultures eat almost nothing but carrion. Their entire survival depends on being able to process rot. So evolution had no choice but to build them a digestive system extreme enough to handle it. Humans are omnivores. We eat hundreds of different foods across dozens of environments. Building a stomach acidic enough to neutralize every possible pathogen in every possible food would come at a massive cost. More energy, more tissue damage, more risk to our own bodies. It was cheaper, evolutionarily speaking, to build an early warning system in the brain instead, reject the danger before it's swallowed, rather than destroy it after. So when you smell rotting meat and feel that wave of nausea, that's not a weaker version of what a vulture has. It's a completely different survival strategy, one that kept your ancestors alive for hundreds of thousands of years without ever needing a stomach that could dissolve bone. The vulture trusts its gut. You trust your gut feeling. Different words, same instinct, both built by evolution to do exactly one thing: keep you alive long enough to pass it on. And the next time your stomach turns at the smell of spoiled food, remember, that reaction isn't your body failing you. It's 300,000 years of ancestors who felt that exact same wave of nausea, listened to it, and walked away.